In a three-phase system, phase 2, typically designated as black, always lags phase 1, usually red, by 120 electrical degrees. This consistent phase relationship is a core characteristic of three-phase power and is maintained without additional circuitry. To address the scenario where two motors are connected to the same drive shaft but require opposite phase rotation due to one motor being flipped, a phase reversal technique is necessary. This involves swapping the connections of two phases, specifically phase 2 and phase 3, to achieve the desired counter-rotation. The most straightforward method for implementing this phase reversal is by interchanging the corresponding wires at the terminal block of the motor intended for reverse rotation. Crucially, before undertaking any wiring modifications, ensure that the power supply to the motor circuit is completely de-energized to prevent electrical hazards. Following the phase wire swap, upon re-energizing the circuit, the two motors should now rotate in opposite directions, effectively meeting the requirement of the shed drive shaft setup. To further elaborate on three-phase systems, it's essential to understand that they are designed to deliver power more efficiently and smoothly compared to single-phase systems. This is achieved by distributing the electrical load across three separate phases, each offset by 120 electrical degrees. This phase difference ensures that power is constantly being delivered to the load, resulting in a more consistent and reliable operation. The 120 degrees separation is not arbitrary, it is a designed characteristic of the generator that creates the three-phase power. The three coils are placed physically apart from each other by 120 mechanical degrees so that the voltage they induce is offset from each other by 120 electrical degrees. When dealing with motor control and phase rotation, understanding the sequence of phases is crucial. The standard phase sequence is typically A, B, C, or 1, 2, 3, and reversing any two phases will change the direction of rotation of the motor. This is a fundamental principle used in various industrial applications where directional control of motors is required. In the specific case of having two motors on the same drive shaft, it is important to ensure that the motors are properly synchronized and that the phase rotation is correctly configured to avoid any mechanical stress or damage to the equipment. If the motors are not rotating in the intended directions, it can lead to binding, overheating, and ultimately failure of the system. Therefore, carefully checking the wiring and phase sequence is essential before putting the system into operation. To properly measure the phase of each wire, you need an oscilloscope. The oscilloscope will graph the sine wave representing each phase and provide timing markers that indicate the different phases. Multimeters often do not show the phase because the signal is alternating and will not provide much data unless it is specifically designed to measure phase. When swapping the motor leads, make sure the motor can handle being reversed. The fan that is typically on the back of the motor is designed to blow air over the motor in one direction only. The direction of the fan is optimized for airflow, so reversing the motor may lead to overheating in some cases. It is important to periodically check the motor temperature to prevent damage from overheating. Also make sure that the loads connected to the motor are allowed to be reversed. Some pumps and compressors can be damaged if run in reverse. The design of the impellers inside the pump or compressor are optimized for one direction of rotation. If the device is run in reverse, it may not operate as expected and possibly cause damage. The motor windings themselves are typically labeled tone T2 and T3, or sometimes U, V, and W. These labels correspond to the three phases of the three-phase power supply. When connecting the motor, it is important to match the labels on the motor windings to the corresponding phases of the power supply. This ensures that the motor rotates in the correct direction. If the motor rotates in the wrong direction, you can simply swap any two of the phase connections to reverse the rotation. In addition to swapping the motor leads, it is also important to consider the grounding of the motor. The motor should be properly grounded to prevent electrical shock hazards. The grounding wire should be connected to the motor frame and to a suitable grounding point in the electrical system. The size of the grounding wire should be determined based on the size of the motor and the applicable electrical codes. When working with three-phase power, it is important to follow all safety precautions to prevent electrical shock and other hazards. Always de-energize the circuit before working on any electrical equipment. Use appropriate personal protective equipment, such as gloves and safety glasses. If you are not familiar with three-phase power systems, it is recommended to seek the assistance of a qualified electrician. Three-phase power systems are commonly used in industrial and commercial applications due to their efficiency and ability to deliver high power levels. They are used to power a wide range of equipment, including motors, pumps, compressors, and other machinery. Understanding the principles of three-phase power is essential for anyone working with electrical systems in these environments. It is also important to note that the phase sequence can be affected by the way the power is distributed in the electrical system. In some cases, the phase sequence may be intentionally changed to optimize the performance of the system. This is typically done by rearranging the connections at the transformer or switchgear. When making changes to the phase sequence, it is important to ensure that all equipment connected to the system is compatible with the new phase sequence. Incorrect phase sequence can cause equipment to malfunction or be damaged. In addition to the phase sequence, the voltage and frequency of the three-phase power supply are also important factors to consider. The voltage and frequency should be matched to the requirements of the equipment being powered. Using the wrong voltage or frequency can cause the equipment to overheat, malfunction, or be damaged. The standard voltage for three-phase power in North America is typically 208 volts, 240 volts, or 480 volts, while the standard frequency is 60 Hz. In other parts of the world, the voltage and frequency may be different. For example, in Europe the standard voltage is 230 volts or 400 volts, and the standard frequency is 50 Hz. When installing or maintaining three-phase power systems, it is important to follow all applicable electrical codes and standards. These codes and standards provide guidance on the safe and proper installation and maintenance of electrical equipment. They also specify the requirements for grounding, wiring, overcurrent protection, and other safety measures. Following these codes and standards helps to ensure the safety of personnel and the reliable operation of the electrical system. Three-phase motors are available in a variety of sizes and designs to meet different application requirements. The size of the motor is typically determined by the power required to drive the load. The design of the motor may vary depending on the type of load, the operating speed, and other factors. Some common types of three-phase motors include induction motors, synchronous motors, and wound rotor motors. Induction motors are the most common type of three-phase motor and are widely used in industrial and commercial applications. Synchronous motors are typically used in applications where precise speed control is required. Wound rotor motors are used in applications where high starting torque is required. When selecting a three-phase motor, it is important to consider the following factors. The power rating of the motor should be sufficient to drive the load. The voltage and frequency of the motor should match the power supply. The speed and torque characteristics of the motor should be suitable for the application. The motor should be designed for the operating environment, including temperature, humidity, and other factors. In addition to the motor itself, it is also important to select the appropriate motor control equipment. Motor control equipment is used to start, stop, and control the speed and torque of the motor. Some common types of motor control equipment include motor starters, variable frequency drives, and programmable logic controllers. Motor starters are used to start and stop the motor. Variable frequency drives are used to control the speed and torque of the motor. Programmable logic controllers are used to automate the control of the motor and other equipment. When selecting motor control equipment, it is important to consider the following factors. The voltage and current ratings of the equipment should match the motor. The control function should meet the application requirements. The equipment should be designed for the operating environment. The equipment should be compatible with other control systems. Three-phase power systems are essential for many industrial and commercial applications. Understanding the principles of three-phase power and the components used in these systems is crucial for ensuring their safe and reliable operation. By following proper installation and maintenance procedures and by selecting the appropriate equipment, it is possible to achieve optimal performance and minimize the risk of electrical hazards. Additionally, consider the use of a phase rotation tester before connecting the motors. This device will measure the phase rotation of the incoming power and ensure that it matches the required phase rotation for the motors. This can help to prevent damage to the motors and ensure that they rotate in the correct direction. Another important consideration is the type of enclosure used for the motors and control equipment. The enclosure should be appropriate for the environment in which the equipment will be operating. For example, if the equipment will be exposed to moisture or dust, it should be installed in an M4 or an M4X enclosure. These enclosures are designed to protect the equipment from the elements and prevent damage. When making any electrical connections, it is important to use the correct size and type of wire. The wire size should be determined based on the current carrying capacity required for the circuit. The wire type should be appropriate for the voltage and temperature ratings of the circuit. Using the wrong size or type of wire can lead to overheating, voltage drop, and other problems. It is also important to properly terminate the wires using appropriate connectors. The connectors should be compatible with the wire size and type. They should be properly installed to ensure a secure and reliable connection. Loose or corroded connections can cause overheating, voltage drop, and other problems. Regularly inspect the electrical system for any signs of damage or wear. Look for cracked or broken wires, loose connections, and corroded terminals. Any damaged or worn components should be replaced immediately to prevent further damage or electrical hazards. Keep the electrical equipment clean and free of dust and debris. Dust and debris can accumulate in the equipment and cause overheating and other problems. Regularly clean the equipment using a vacuum cleaner or a soft brush. Avoid using water or other liquids to clean the equipment, as this can cause electrical shock hazards. Ensure that the area around the electrical equipment is well ventilated. Poor ventilation can cause the equipment to overheat. Make sure that there is adequate airflow around the equipment to dissipate heat. Do not block the ventilation openings in the equipment. Regularly test the grounding system to ensure that it is functioning properly. The grounding system is designed to protect against electrical shock hazards. It should be tested periodically to ensure that it is providing adequate protection. Use a ground resistance meter to measure the resistance of the grounding system. If the resistance is too high, it may indicate a problem with the grounding system. Consider using surge protection devices to protect the electrical equipment from voltage surges. Voltage surges can damage sensitive electronic equipment. Surge protection devices can help to protect the equipment from these surges. Install surge protection devices at the main electrical panel and at individual equipment locations.